Good evening. My name is Apieta, and I'm going to be continuing from where my colleague stopped. This slide summarizes our core techniques that we used in our system. For the image classification, we used the hybrid CNN, and which was based on the efficient net and to classify the histopathology images. And for the model, and then for the risk prediction, we used the random forest model, and we explained it using Sharp. And also, we implemented the retrieval-augmented RAG pipeline. And this was to allow the system to retrieve trusted clinical guidelines and generate accurate and evidence-based responses. And then for the next slide, we had a literature review that showed that breast cancer remains a major health challenge in Uganda due to a bunch of reasons like late diagnosis, limited specialists, as well as high costs of treatment. And previous studies have demonstrated that deep learning models can achieve high levels of accuracy that may be currently lacking in medical image analysis. And then explainable AI methods like Sharp can improve transparency, while random forest models are effective for clinical risk prediction. Research also shows that RAG systems can help reduce hallucinations. However, there's still the gap of there's no existing solution that combines image classification, risk prediction, and explainability, as well as conversational clinical support into like one unified system. And then we had our system architecture. This slide just illustrates our overall architecture of the system. We have the histopathology images are enhanced using the CLA, HE, and then processed through the efficient net and the HGLCM feature extraction to produce the prediction, supported by visualizations. And then you have the risk factors that are analyzed using the random forest model to generate a risk score. And these results are passed to the retrieval-augmented assistant, which retrieves the relevant information from medical guidelines stored in the FAISS database. And all these outputs are then presented on our interface, our base interface that allows the users to kind of receive explanations towards their predictions or recommendations, depending on what has been found. Then we had our implementation. For this implementation, we used Python together with TensorFlow and FAISS, and then also LangChain. And so images were pre-processed using CLA HE enhancement, resizing, and then normalization and augmentation to improve our model performance. And then the HGLCM extracted 72 texture features from each image, and that now the efficient net was trained in 2 phases, with fine-tuning significantly improving our classification performance. And then for the risk prediction, Optuna was used to optimize the model, and then Sharp generated feature learning explanations. And then the results, and for this slide, the results demonstrate strong performance for image accuracy. Our hybrid CNN achieved an accuracy of 87.7% with a precision of 92.7%, which was an indicator of a good and an almost excellent ability to distinguish between benign and malignant cases. And then our random forest was able to achieve above 60% accuracy, which was limited by use of synthetic data and a number of features. Although some overfitting was observed during training, the high test AUC confirms good generalization. Overall, the results show that image classification could be highly effective and suitable for further clinical validation and deployment. Thank you.
Good evening. My name is Karunji Maria Duffin from Group 11, and I'm going to continue from where my other group member stopped. So for the impact and relevance of our project, this project addresses an important healthcare challenge in Uganda. That is where access to breast cancer specialists is limited. Then it also aligns with the SDGs, which are SDG 3, 9, and 10. Then it's also an AI force multiplier, whereby it augments existing healthcare workers with automated preliminary analysis. Then our target beneficiaries are clinicians, patients, and health systems. Then for our intellectual property and innovation, the key innovation of this project is the integration of multiple AI technologies into one unified platform. So we combined efficient net, image classification, as well as XAI Sharp attributes in this project. Then our deployment innovation, it helps in scalability and resource efficiency. Then for our explainability results, we use GradCam to improve trust and transparency, where we used it to incorporate different technologies. We use GradCam heat maps that highlight the tissue regions that influence malignancy predictions as well as benign predictions. So our results have a coverage, malignant cases, and false positives. For explainability results, we have a RAG pipeline performance that explains the results to you. And our pipeline was based on 4 key things, where we have a retrieval accuracy, the citation correctness, a response relevance, as well as the factual grounding. Then we have a Sharp feature importance, where we have a top predictors, which is age, symptom duration, and family history, the low risk profile, the high risk profile. This is for our risk model that contains risk factors for breast cancer. Then we also carried out exact same testing, where we got participants and they used our deployed model, which is through an app on our website, and then we evaluated it and had our results. which were usefulness, clarity of results, ease of use, and overall satisfaction of the app when they were using it. I also got feedback from the clients, as well as the positive feedback and the suggested feedback. Thank you very much.
Hello, it's Automated. We take the next parts of the slides. So looking at the result discussion at high classification accuracy, where we achieved an ROC over 0.9 and then a precision of over 92%, which indicates basically that this model has a high ability to distinguish between the benign and malignant samples. And then we also the explainability. The model is not just going to give you results, it's able to explain and tell you the major factors that affected its reasoning, guideline grounding, the RAG, also resource efficiency. Yeah, then weaknesses. So based on all these accuracy, however, in the risk model, the risk prediction model, we achieved a low accuracy of 50.2%, which was majorly because it was trained on synthetic data with limited features, only 4 features, and it couldn't achieve a higher accuracy. So looking at this demonstration of the test case 1, where we have the original pathology image and then the breadcrumb. So this was the image that was analysis, and then this is a breadcrumb telling you which specific points affected the decision. Like you look at this red tissue attention map, like these red points on the tissue attention map. These are high risk areas, and classify like tumors that the model detects, and is like, yeah, this be our sample. It gives you the result and shows you this tissue attention map. Okay, so we have this Hugging Face space where we deployed our model and it's currently running. Yeah. So basically here you upload the histopathology image and you interact with the risk model where you input the patient's details, yeah, family history, the same duration, and then reproductive history, whether it's early menarche or nulliparous. Early menarche is like the person who started having menstruation at an early age, and then nulliparous may be someone who has not given birth to a live baby yet, miscarriages, abortions, and all that. Then history of breast cancer in the family. Yeah, so let's get into it. Have these images, malignant samples, and then the samples. Let's just get benign sample, drag and drop, and then yeah, enter these values, or you can use example scenarios. And then we run assessment. When you run the assessment, it's able to produce clinical report and then the breadcrumb explanation. So yeah, it clearly finds it's benign, the confidence of 99%. Then it gives you all the recommended clinical actions based on where you gave here, so the guideline. Yeah. So also have the breadcrumb explanation, which tries to show you the red points. The red points, which are regions which are most influential AI decision, and then blue points, less influential reason. So let's try an sample. Let's clear this. Sample. It's going to open on this. Then you run the assistant. Then, well, you can also edit this clinical query so that you can get a well-tailored guideline to tell you the next steps. And so, yeah, it clearly classifies it as with a confidence of 99.15%. So we also had the mobile app, which pretty much is also using Gradio API from the Hugging Face deployed model. Yeah, so you open it, it tells you the total scans, high risk, which are 12, and then the recent assistant scans, which you can open to review. And then down we have the breast cancer news. Yeah, this is using the news API basically. And then we have the assistant where we are going to be testing this from. So it pretty much has the same things on the website. You have to upload an image. I'll just upload it. It's a benign sample. Then after uploading, I'll choose the information, family history, let's say yes, active history, whatever, then run AI assessment. It should be able to give us the classification. Yeah, so we can see it's a benign sample with a confidence of 99.98%. Then the patient's profile and the explainability, the texture interpretation, yeah, all those, and then also the breadcrumb output. Yeah, so basically that's it.